I want to talk a little bit more about this concept of bias. And so at my university, at Ohio State University, we have a very good basketball team. And let's say that one of the key players on the team decided to leave the university early to go play in the NBA. And that meant that there was one position still available on the team for somebody to fill his place. And so they held tryouts with all of the students at the university to fill this last position. And after all the tryouts, we were down to 2 students. There's only 2 students left, and we have to make a decision about which one is on the team. So, so here are the 2 students, student A and student B. And here's student A, here's student B. Now, the idea is that each of the students is going to shoot at the basket, okay? And here's how student A did. Student A shot like this. Student B shot like this. Now, actually, I'm going to make student A miss all the time, but do it like that. Okay? So, which student should we choose? Should we choose for the team student A, who in practice scored no points, or should we choose student B, who scored some points? Now, you may think about that and think, okay, which one would I choose? But if it were me, I would choose student A. And why would I do that? Because student A is clearly not seeing the right basket. If we got them some glasses, they could see where the basket was because they could do whatever they were doing in a very accurate way. Okay, so by adjusting where they were aiming for, they would score a lot of points. This student's seeing the right basket, but just isn't very precise and isn't doing it very accurately. Okay, so you can adjust for bias. Another example of this is, and this is a true story, I was at a place in Copenhagen called Tivoli Gardens. And Tivoli Gardens had, when I was there, had a shooting gallery. And the shooting gallery was such that you would take your rifle and you would aim at a target, but the target was reeled to the back of the gallery. And then you would shoot at the target, and then they would reel your target in, and you see how you did. So actually, I heard this story from a colleague who went there the night before, and he came back and explained that when he went to this shooting gallery, his shots were like this when they reeled it back in. And he was very upset with his performance because he didn't score any points and he didn't get any kind of prize. And then he said he went to dinner and he thought about this, and then he went back to the same shooting gallery, and this time, instead of aiming here, he aimed here. And as a result, he was able to hit the target many times and won a prize. So I decided to go to this place, Tivoli Gardens, the next night, and to see how I could do. And so here's my target. And what happened was that the first time I shot at the target, I shot once, and I asked them to reel it in so I could see how I did. And in fact, I hit the target. And then they reeled it back, and I wound up hitting the target most of the times, and I missed once, but I won a stuffed banana. So that was my prize, a stuffed banana, and it really proved that I could show that the rifle was unbiased. So I was using an unbiased rifle. He was using a biased rifle, but he could adjust for bias. Okay, and that's the important thing in statistics or in epidemiology, is that although we may have a biased estimate, if you know about the bias, you can adjust for it. So it's a very important point. Okay, so now, bias is not always the most important issue. Sometimes the most important issue is a combination of bias and variance. So, for example, let's suppose that you were a drug manufacturer, and you were manufacturing a drug that was to be used for patients who had a particular disease. Now, this disease is a horrible disease, so that if they don't receive any drugs at all, they die. Now, on the other hand, if they get treated for the disease, and the treatment is 10 milligrams of a particular tablet every day, if they get 10 milligrams of that tablet every day, they can live a normal life. On the other hand, If the tablet is not 10 milligrams but is only 8 milligrams, they'll die of their disease. But if the tablets are really 12 milligrams, they'll die of an overdose. So it's very important that the tablets be produced in an unbiased way, but not just that the average per tablet is 10 milligrams, but also that be virtually no variability. It has to be no bias, but low variability. No bias alone is not good enough if there's large variability, because that patient would die. Okay, so it's the combination of bias and variance that's important.